Okay, so if we're going to test if two graphs are inverses of each other, we need to look at the points that are reflected across from each other. So basically, these two, these two, these two, and these two. Now what you might notice, let me write one of them down. If I have negative 4, 0 as one of the points, and the inverse is at 0, negative 4, you're going to notice this pattern where all that's happening is the x's and y's are switching. So if you wanted to test if something is inverse by looking at this picture, you just have to verify that the every single set of points switches order the way that it did just as I showed you. So describe the pattern between the pairs. The x and y values switch. That's the main idea. So I've got a couple of questions that I wanted to share with you because I don't know of any other way to show you other than just giving you the answer. So there are questions almost identical to this on the test. So the main idea here is, like if I give you a point, let's just call it A and B. The inverse would be B and A. If it's 1 and 2, the inverse would be 2 and 1. So I don't like calling it the opposite because to me, just in math in general, opposite means to change the sign. So I don't like doing that. So I say it switches the order. So in this question right here, when it says if that point is on f of x, then what point is on the inverse? Well, that's clearly going to be y1 and x1 because the idea of the inverse is that the x's and y's just switch. Now there's also this idea that goes along with x's and y's called the domain and the range. So if this is the domain and this is the range, and then that makes this the domain and this the range because the domains are the x's, the ranges are the y's. So if you compare the A over here, it ends up in that spot. So basically what happens is when you have an inverse, the domain becomes the range. And I don't know what this line is here for because this right here is the answer. So if two functions are inverses of each other, the domain of f of x becomes the same as the range of the g of x function. So today's lesson is on graphing the inverse. So I give you a set of points, and then you have to find the inverse and then graph the inverse. So I'll show you some tips that could help. So the first thing I do is I start at one of the dots, maybe at one of the ends, and I write down the values. So this is at negative 2, 4. That means the inverse is going to be at 4, negative 2. Again, we're not changing signs, we're changing the order. And I'm just going to trace the line and end up at this point. That point is at 0, 3. So that means for us, the inverse would be at 3, 0. And I keep going along the point, or the line to the next point. That's at negative 3, positive 1. So that means that our inverse is at 1, negative 3. So the reason I like doing it in order is because that's going to show us how to connect the dots once we have the inverse graphed. So we go to 4, negative 2, 2, 3, 4, negative 2 is right here. And we go to 3, 0, 1, 2, 3. And then we go to 1, negative 3. 1, 1, 2, 3. So some people don't know how to connect the dots. So part of the reason why we do them in order is because we connect them in the same order that we have them written. If you remember, the first one we had was 4, 2, 4, negative 2. We went over to this one, then we went over to this one. I want to tell you this fact right here, because this can also help you draw your pictures better. There is this line of symmetry. It's a diagonal line of symmetry across the equation y equals x. A line of symmetry basically kind of acts like wet paint. Imagine having wet paint. Let me go into this line and just make it a little bit thicker. So let's say this guy right here is wet paint. If I take this graph and I fold it across the green dotted line, it's going to stamp an image on the other side, but it's going to end up backwards. So there's this idea where if I fold the paper, this thing's going to flip over to this side and be backwards. And that's how you can kind of help yourself draw these lines. You'll also have to be able to do this for a curve. So same strategy. I'll just start right here. I'll call that the starting point. So it's at negative 3, 0. The next one is at negative 4, 1. And then the third one that I've given is at 1, 2, 3, 4, 5, 6, 7 to the left. And then 2 up. So to find the inverse, we would switch these. 0, negative 3. 1, negative 4. 2, -7. So then we plot them, 0, -3, 1, 2, 3, 1, -4, and 2, -7. 1, 2, 3, 4, 5, 6, 7. Now again, if you don't know how the curve is supposed to look, we can always add this extra dotted line, and the red one is going to be opposite of the other one. It's going to flip over and be backwards. So if this right here is your starting point, it's going to go this way. It's going to come like this. And you can use that whole idea of wet paint again. This guy flips over and comes over here. Okay, and then the last one, this is where that line of symmetry might help a lot. So I'll start at this one. It's at 1, 2. Then this one is at 3, 1. And this one right here looks like it's at 5, 0. So if I do the inverse points, I get 2, 1, 1, 3, and 0, 5. So we plot the points, 2, 1, 1, 3, and 0, 5. 1, 2, 3, 4, 5. So this one's a little bit harder to see. We're not sure kind of like how to make the curve. So that's where that diagonal line will come in. So I'm just going to kind of focus on this part. If I focus on this blue part right here, it's got to flip over and come this way. So that's what this should look like. So that kind of helps me figure out that the curve's going to go like this and then like this. And so that's how you do inverses. Find the points, switch the order, regraph them, and use the diagonal line to figure out how exactly to draw your picture.